Oh, okay. So this is just a brief revisiting of um, what's the word? Oh, unit conversion and what's called in fancy language dimensional analysis. Okay. Here's the deal. You can report things in a bunch of different units. Okay, but so if we want to determine, or if we want to put 400 feet per second into a different unit of speed in meters per minute, we can use unit conversion. You're going to have to use this all year. Okay, now, you could do this a couple ways. You could do it by proportions and stuff. I need you to be able to do it both ways for some of the stuff that we're going to do. Okay, so here's the deal. We want to express this same measurement of speed just in different units, but it's going to be the same thing. We want it to end up just in these units in meters per minute. Okay, so here's the deal. Units can act just like algebraic variables. Okay, and all that means is that just like if you had x squared over x, you would tell me no problem. Oh, if you wanted to simplify that, that's equal to x, right? That this would cancel out. Oops, I guess you can't x over an x. Like that, right? Okay, so similarly, units can do the same exact thing, which means this. If I put seconds up here, what would that do if I multiplied it? I could get rid of them. Okay, so now the second part of using unit cancellation is this. What is the one thing you can multiply anything by that doesn't change that thing's value? So for example, 17 times 1 is 17. 24,311 times 1 is whatever number I just said. Okay, so what we need to do is make sure that we're multiplying it by whatever we're multiplying it by, make sure that it's equal to 1. Okay, so how do we do that for a fraction? Well, for a fraction, 17 over 17 is 1, right? So is 9,180 over 9,180. So we need to make sure that what's on the numerator is exactly the same thing as what's on the denominator, okay? So just like here, we want to change this unit of seconds into minutes. Okay, so now we've done that. What's going to happen here with these units is they will cancel out. Okay, but what did we need to make sure? We need to make sure that what's on the numerator is exactly the same value as what's on the denominator, and that way we're not changing the measurement that we've made. Okay, so now if we were to evaluate this, it would be in feet per minute. Okay, however, we want it to be in meters per minute. So what we would need here is, what unit do we want on the bottom to get rid of? We want to get rid of feet and change it to meters. So the thing that you would need is just whatever that conversion factor is, which is very easily looked upable. And I believe it's like 3.281 feet per meter. Okay, so now what happens to these units? Please be careful. These don't cancel out, right? How come? Because this is minutes. That's meters. But this cancels out with that. So now all we have to do is do 400 times 60 divided by 1. You don't really need to. Times 1? You don't really need to. Divided by 3.281. And whatever that number comes out to be, that is going to give you this measurement with meters per minute. Okay, I hope that that is helpful. We can do this for all types of measurements. How do I